My name is Evaldo. I'm a director of business development with FairCom. And I'm going to talk, I'm going to dive a little bit deeper here. I'm going to dive a little bit deeper here on the infrastructure side of the financial solutions, where I actually have a database. And I was just sitting there watching this super cool demonstrations they had here, like had a camera, they had a POS, and I was like, oh man, I was jealous because it's such a fantastic demo. And there's nothing more boring than a demo of a database, I guess, showing how a database works. But don't worry, I'm not going to demo my database here. What I'm going to do is actually share with you some of the views, insights we have on what's the role that databases are playing on innovation for fintechs. And we have a lot of customers on the financial industry. So just to set the ground here, we talk a little bit about us, who is FairCom. So we're founded in 1979, so we've been on the road for a long time. Always focused on primarily data methods, and then it evolved to databases. We have customers all around the world, as you can see here. Majority of the customers use us as an embedded database. I'm gonna talk primarily what we have. Some of you already stopped in our booth over here. We have a non-SQL database, and you saw from the beginning of the slide here, that's the main topic here of innovation. So just to understand here, some of our customers right now that use this technology, some of them are really large customers like Visa or FICO. In most cases, they use us primarily because of performance reason. So this is a very high speed, high transactional database. It's designed for high throughput. But at the same time, they also need to integrate this database with other things, so other technologies. So SQL is a big part of the problem here. But looking into the database and looking into innovation, what's going on with fintechs. So here's a graph showing you what's going on with funding in fintech right now. So you can see LHS is for left-hand and right-hand side. So that's actually how many people are funding fintechs right now, how many companies are looking for funding in fintechs. You can see it grew from 2013. The numbers are a little bit older. I'm going to show a newer one there. 2013, it was about $4 billion invested. It jumped to almost $12 billion in 2014. And the numbers actually last year, there was a research from Accenture showing that it's already about $22 billion invested in fintech. And you guys are deeply involved in this. You really understand what's going on, right? There's disruptive market. There is innovation coming inside existing markets, right? So the collaborative market is moving as well. Some industries are really completely being reshaped. What are the main drivers of this change? So there's a research here done by State Street Investments. They named 5 main topics here as being the drivers of this change. You can see blockchain, of course, right? Everybody knows about that. Predictive analytics, it's a big force here. Real-time payments, so payments are shifting to become real-time. Most of you are aware that payments are usually batch processed, so they run in the background. That you have time to process the payment and all that. Well, this is shifting, it's moving to real-time. AI, artificial intelligence with machine learning, and biometric authentication. So these are the 5 main technologies. What I think affects directly the database industry is predictive analytics and real-time payments. These are deeply important drivers that really we see our customers innovating in this area, and it's affecting what database they are using. Okay, so looking a little bit deeper on each one, let's look into predictive analytics first. So what's driving predictive analytics, it's mainly social media and everything that comes with that, right? So social media, the fact that you can, you know what your customer, you can know what your customer, your consumer is doing by looking into his life. It's a major driver here. You can see here, for example, for sentiment analysis, trying to understand what you're going to buy, or identification of market trends, trying to help your customers to make better investment decisions because you understand there's a major shift on this direction or on that direction. I just heard a major country, they have a project, the IRS of this country has a project where they searched the social media of the persons to try to understand if he has a ton of pictures in a boat, but he's reporting $50,000 per year, the IRS will say, oh, wait a minute, there's something weird here. You're going to have to explain, this boat was my friend, not mine. So this is really, it's really affecting a lot, this whole market. And a lot of this predictive analytics, from the database perspective, it's typically non-relational. So for those that are not familiar with the relational, non-relational, the non-relational is the new NoSQL. Okay? So the database industry decided that actually SQL and NoSQL was too much. It's not only about that, right? SQL or non-SQL, and non-SQL is almost like a negative term. So they decided non-relational makes more sense because there are so many different types of data that you want to store in a non-relational format, which means essentially you don't have tables, okay? You don't want to have relationship between tables. That's not really the best way for you to store your data. Social media, again, it's typically non-relational. You have friends, which is more like a network, right? You have the videos on Facebook, on YouTube that you watch. This is more like it's almost like really like a graph of interrelationship between different types of data. The fact it's also flexible data is also very critical here because this data changes all the time, and it's not very well. You don't have a very well type. It's not only about how much did I sell, name, address. No, it's all the tags that you tagged on a video you liked. The likes you gave on a Facebook page, and all this. So NoSQL definitely is a big driver behind predictive analytics. Look into real-time payments. Yeah, this is going on right now, really. It's really, really strong. So you can see it on the right here. That's a graph from ACI. ACI is actually one of our customers. They're showing here any-to-any payments. There are many different ways that payment is changing here. And I guess what we have seen from the back end down in the infrastructure, the questions are coming in sense of what kinds of other data can I integrate into your database? What kinds of other types of data can I plug in and store in your database? But I don't want to do a search, just an SQL search. I want to be able to query relationships across this data. So it's getting really complex. And you have another graph here showing here how this is evolving across the world. Some countries already have real-time payment. It's coming to US. You can see US is not completely real-time payment yet. It's probably most of you already sensed it. But there are places there you can actually transfer funds and see in minutes it's actually in a different account. So what's the big deal about real-time payments? The problem is that payment, usually you have the time to process payment during the night, which means you can check accounts. You can see if the balance is there. You don't have necessarily to run the risk to transfer funds immediately. What's more risky about payments right now is really the ATMs, where you can have to cash money right away. And then in most cases, the banks decide how much risk they want to take, but still processing is going batch. When you switch to real-time payments, that changes completely. You have to decide right away if the balance is there. There's a hidden part of real-time payments, it's related to telecom, mobile, prepaid phones, for example. There are countries where you have to when you make the call and you're using a prepaid phone, you have to check if you have balance to complete the call. But there are regulations around that saying if you don't check the balance in X milliseconds, the telecom company is forced to complete the call for free. So that's a major revenue loss for the telecom company. So it's almost like a payment system running in the background to support prepaid phones. So you can see this is affecting the whole industry. But the bottom line behind real-time payments is that it needs to be safe. Right? You have to be sure that what you're doing is actually consistent with the balance on both ends of the application of the accounts. So what does it all has to do with database? So this drills down to an acronym here called ACID, okay? And it's not the ACID. It's ACID for atomicity, consistency, and I should be wearing our shirt. We had a nice shirt full of colors here, and I was like, "Are you ACID?" And when our president, when he saw that, said, "Oh no, I don't want to be associated with that concept." I said, "No, don't worry, it's just cool." Yeah, well, I should be wearing it. Unfortunately, I'm not. But ACID stands for atomicity, consistency, isolation, and durability. But without drilling into the details here, getting lost in the weeds here, this is essentially what supports transactions when you want to be able to say atomicity means it's either all or nothing. Okay, if I cash money from this account and deposit on that account, and something goes wrong in the middle, the whole thing is canceled. Okay, I cannot cash over here and not deposit over there. Okay, so you have to treat it's all or nothing. Consistency means I cannot update a record, for example, and just update part of the record and the server breaks down and the rest of the record has not been updated. So that's a problem, big problem. Isolation means that if you're updating a record and someone tries to come in and tries to update the same record at the same time, it has to wait in a serial mode. Okay, so you cannot just compete across the same record. And durability. Durability for recoverability. If everything goes down, when you come back, everything needs to be consistent. You have to be able to recover everything. So it's a very common concept from the old relational database world that is very relevant right now for innovation. Let me tell you why. Because there's the other side of the fence. Okay? What they call base. So software people like to be funny, right? So base stands for basically available soft state. Soft state, I think it's important here, means you can have a situation where nobody's trying to change anything on the database, but the database is still going on and doing changes by itself. And most important, eventually consistent. What does eventually consistent means? It means that you can have an update on a database, and eventually everybody trying to access that update is going to read the same value. Okay? Well, eventually, it's going to read the same value. So you can ask yourself, why would someone eventually read the same value? Because it's designed to scale horizontally in hundreds of servers. And you might decide, you know what? I can just update the servers and go updating the servers, each one of them as I need. And I don't worry so much when I read that last update if it's actually consistent with the last write. Okay? This is very true in some industries. When you go to Google, for example, you don't worry really if you are reading all searches that you were searching for, right? You get the best one of them. This is really critical for databases, right? Because of what we call the cap theorem. The cap theorem states that you cannot have all three characters at the same time on a database. You cannot be on a distributed system. You cannot be consistent, available, and tolerant to partition, having multiple modules. You have to give up on something, okay? Traditionally, relational databases were always giving up on partition tolerance. They were always consistent and high available, but not partition tolerance. Well, non-SQL databases, they came with a different concept. They are highly available because they're distributed, they're partition tolerance, they're all over the place, but a lot of them gave up on consistency. Okay? So they are eventually consistent. And that's a major problem for some financial solutions. Okay? And that's I guess the trap I would like to show to you guys here. You have to be careful. Sadly, it's impossible to have everything, okay? As we learned so hard in our life, right? We can't have everything, and I'm going to show you a little bit here. Let me go quick here because I'm almost running out of time here. The big question here is really, is it safe? Right? Can you use non-SQL, non-relational database if you want to try to innovate in fintech? So when you look into traditional markets, they're all running in a pure relational database. You want to innovate, so say, oh, I should use a non-SQL database, right? Because that's the way to go if I'm involved in real time or predictive or all that. You have to be careful. You cannot run away from the cap theorem. Okay, there's no free lunch here. And if you are giving up on consistency, you have to make sure, or at least be aware that you're giving up on consistency. We saw a lot of projects that failed. In some cases, some of our companies, you saw in the beginning, they are large enterprise companies. They have like many startups coming inside their own organization. They call it the bimodal company. So they start like little startups. And these projects, they just pop up like mushrooms. And a lot of them are like people come out from outside. What you doing? Oh, I'm doing this. And so, wait a minute, but this is not consistent. Oh, yeah, but it scales everywhere. I can go to the cloud. Yeah, but it needs to be consistent. and that's a big thing, okay? So let me show you here. It's the question really between eventually consistent and ACID, okay? So why FairCom? Well, we are what we call the new generation NoSQL. So we have not only NoSQL, but we have also SQL. Okay, our database supports both things. It has been designed many years ago, but has been evolving. It's currently on version 12, so it's a very robust core technology. The non-SQL side is designed for high performance and supports transaction. Okay, so it's designed for ACID compliant. It's being used mainly for systems that require that. And on payment, for example, I guess it's a good example. We have several customers that use us as the database behind payment. I guess the best example is really Visa in Europe, in the UK. Every time you travel to an European country and you swipe a Visa credit card, it's our database holding the authorization behind the back end there. They don't really care about relation. They never care about relation. And it's almost like funny when you talk about, oh, the non-SQL database. They're like, we are always NoSQL. Yeah, it's true. Some applications have always been NoSQL, and I think this is an important message to deliver here too. Non-SQL is not new. Right? And the concept of NoSQL has been there since a long, long time. What's being new is giving up on consistency to focus on scalability. Okay? That's actually new. It fits very well some, like for example, if you query documents and you don't worry really so much about consistency. But for payments, that's absolutely critical. In our case, you don't have to give up on SQL if you want to use our fast index engine, because we also provide SQL on top of the same data. And we provide SQL with transactions. So we also support transaction on this end. Here's a little example of a code. Okay, so it's a C code showing how transaction works. The only reason I brought it up here is because I was jealous of all the people writing codes here and showing live demonstrations and all that. But you can see here, and I would like to point something out here. This is where a transaction starts, and this is where it ends. So to be atomic on the asset here, it needs to be, if something happens in between here, for example, the whole thing rolls back, okay? The database makes sure that it's not only one record being updated or another record being updated. Both of them or none of them needs to be updated, okay? And all the rest is really here. Durability. Durability is really, really critical for recover. So when everything is going on here and you update the records at this place here, first thing our database does is making sure it goes to the disk without impacting performance. That's the beauty of the key value store here. So we make sure it goes to the disk in parallel while you're updating your records so that you can recover in case the transaction actually finishes and commits. Okay? So it's a good example of what you can do. If you search on the internet, you're going to find at least there are some public, very well-known situations of companies that they try to use non-SQL databases for payment. Like there's a very famous one related to Bitcoin. It was like a big flop. And the problem was really they took advantage of this. It was a major attack of withdrawing and depositing multiple times, and in between, something was inconsistent, and you were able to cash some money out of the system without having the proper balance on the other end. This would never happen in this situation here, okay? So I'm taking your time for questions here, so I'll be available there for more questions. Let me just keep over here while I show you some of the examples here. We have one of our customers. It's innovating with our technology and looking to what else they can do. Time series is a perfect example, what you can do with time series. So in most cases, our customers are processing like 10,000s to 100,000s of messages coming in, streaming, okay? And they have to take this data and store it in disk as fast as possible while they're also doing analytics on top of it. So persistence, durability is really critical. Transaction is really critical here. What they are doing, so using our SQL plus NoSQL, we allow them to regroup these messages into small chunks, write them into a single record, like hundreds of sub-records into a single record. This is the beauty of the key value store technology. You can have keys here and values here. They can be very flexible in the schema. But from the SQL side, we reorganize everything. So you can have streaming coming from here, taking advantage of all this, and using SQL to query this information and doing analytics and predictive analytics and all you want to do. So the combination of both technologies is really the key point here, okay? So here's my little demo. It's actually a video just showing my database. I thought, okay, let me show at least something working here so you guys can believe it does exist. But it's essentially a really low-level database designed for high-volume transactions. And I'm sorry I ran out of time. Here are my final thoughts. If you want to innovate, and you're going to touch your database, and the database is critical for your innovation. Be careful with the pitfall of the cap theory. Okay, don't just assume, oh, I can have 3 of them. No, you can't. And in the majority of the cases, non-SQL databases are giving up on consistency. Okay, so do that. It's okay to innovate with that, but do it in a conscious way. Okay, thank you very much.